Okay, so the second part of section 7.2 is going to be solving triangles and talking about angles of elevation, angles of depression. So, first of all, how to measure these angles here. This horizontal line right here is what's called your sight line, or your line of sight, or your horizontal. Okay? So imagine that you are standing here, that's you, and you're looking, you're happy. Looking straight ahead is your sight line. If you have to look up, the angle at which you have to tilt your head to look up is called the angle of elevation. So if you're looking up at the birds. If you look down from your sight line, that's your angle of depression. So that's the little bug down there that you're looking down at. Okay? Both of these angles are measured from this horizontal, from this line of sight. Okay? That's what's going to be important to notice about these angles. So, looking at the top of a building, so sighting the top of a building, a surveyor measures the angle of elevation to be 22 degrees. The transit is 5 feet above the ground. Now, the transit is the measuring device that surveyors use. Okay? It's 5 feet above the ground and 300 feet from the building. Let's find the height of the building. All right, so I got a little picture here for you. The transit is this little device here. It's just kind of standing here. Maybe it's got a little tripod or something that's standing on. That's not an armless person. 5 feet off the ground. And then it's looking up at the top of the building. The building's 300 feet away. We want to know the height of the building. So here's your building. So let's put some little windows on here for you so you know what you're looking at here. There we go. And of course I hit record, so now my dog decided that she's very thirsty and very itchy. So, okay, so this angle of elevation is 22 degrees. So what angle is that? Well, let's talk about the horizontal. If this transit was not tilted at all, the horizontal would be right here, parallel to the ground. That's the sight line. So the angle at which the transit had to be tilted up is this 22 degrees. Okay? So we get that 22 degree angle of elevation. Now if you look, we've got a right triangle right here. It's going to make a right angle. So we get this nice little right triangle. Now I bet you know what this distance is, this base of this right triangle. Well, it's 300 because it's the same as that. So we have a right triangle, right? See it? So we can use some right triangle trigonometry. So we get 300. We have 22 degrees. And let's find this distance over here. I don't know what to call it. I'm not going to call it h because h is the full height of the building. And this part right here is not the full height of the building. That's just part of the height. Right? So, I don't know. Let's just call this y. What trig function should we use to find y? Well, if you think of right triangle trigonometry, this is the opposite and this is the adjacent. So what trig function uses the opposite and the adjacent? We don't know this distance right here. We don't know that diagonal. So we don't want to use the hypotenuse. Well, it's going to be the tangent. So we have the tangent of 22 degrees is the opposite over the adjacent. So that's going to be y over 300. We can solve this for y by just multiplying both sides by 300. And then if you just break out your calculator and do 30 times tangent 22, make sure you're in degree mode when you do this. Right, so we want to make sure, if we go to mode, you can see that degree is highlighted, so that's cool. All right, we're going to do 300 times the tangent of 22. We get 121.2. All right, so is that our final answer? No. That is just this height right here. By the way, this is not drawn to scale. So this is the 121.2. Well, what's the rest of this height right here? So we know that this is 121.2. What's that distance right there? Well, that's the 5. See what I said about not drawing to scale? Because to the casual observer, it looks like these are the same distance, right? But you got to like tilt your head and squint or something to see the difference. It's not drawn to scale. So anyway, if you add those two together, you get the total height of the building. All right, so I did that a lot prettier on here, but there's everything that I just did. So the important thing with these is to know how to draw the right triangle that's going to result from these angles of elevation or angle of depression. All right, so next up is going to be solving a right triangle. So solving a right triangle means finding the lengths of the missing sides and finding the measures of the missing angles. Now, standard labeling here. Standard labeling is going to be A, B, hypotenuse is C. The right angle is always opposite the hypotenuse. This is the Greek letter alpha. This is the Greek letter beta. Okay? Alpha is always opposite A. Beta is always opposite B. Okay? So we've got alpha and we've got beta. I do that because in your book and in WebAssign, they'll use the symbol angle capital A. I don't want to call this capital A because then as I'm talking, you don't know if I'm talking about A or A. So to avoid confusion, and because it's really very common to use Greek letters for angles and our normal letters for sides, okay? But just know that angle A is the same as what I'm calling alpha. Angle B is beta. It's important, B and beta are always opposite each other, A and alpha are always opposite, C and the right angle are always opposite. Now, there's a couple of things we know about right triangles. We know that the Pythagorean Theorem holds for right triangles. A squared plus B squared is C squared. We also know the sum of the angles in every triangle is 180 degrees. That means my right angle plus alpha plus beta is 180. Now, what that means is also that alpha plus beta, those two, must be 90, right? Because 90 plus 90 is 180. So you can kind of use that little abbreviated version of this. And we've got our right triangle trig. You know, we've got this whole opposite of our hypotenuse, adjacent over hypotenuse, opposite over adjacent business. We're going to use these all together to solve a right triangle. I mean, find the missing angles, find the missing lengths. All right, so let's solve the right triangle where alpha is 61 degrees and B is 39.2. Okay, remember alpha is the same as angle A. All right, it is a right triangle, so we're just going to draw a right triangle. Remember my standard labeling here. A, B, C, alpha, beta. So here's what I've got so far. I've got that B, not beta, B is 39.2, that side length, and I've got that alpha is 61 degrees. So where should I start solving this? Well, I'm kind of drawn to beta because I know that alpha plus beta is 90 degrees. So if alpha is 61 degrees, beta is going to be the rest of the 90, right? The complement. So subtracting 61 degrees from both sides. So if you want to take 90 minus 61 degrees, I'm going to get, what, 29 degrees? So there's one of the missing angles. Now I just have the two missing sides. Okay, so beta was the first thing that I found. So let's see, which side do we want to find next? Well, this kind of depends on your preference. You can use either one of these angles. I'm just going to choose to use alpha here. I don't know the opposite. I don't know the hypotenuse. So the sine function is not a good choice because I don't know this or this. I want to use a trig function that's going to involve the adjacent and the hypotenuse, or the adjacent and the opposite. Something that's going to involve the adjacent, because I know that adjacent side. So how about we use the tangent? Okay? The tangent of 61 degrees is going to be the opposite over the adjacent. So the opposite is A, the adjacent is 39.2. So I get that from the right triangle trig definition of tangent. To solve that equation for A, I have to multiply both sides by 39.2. Grabbing the calculator, we get 39.2 times tangent 61 degrees, and we get A is 70.7. Lastly, we have C. You can use right triangle trig, or at this point, you know two of the sides of the right triangle, so you can use the Pythagorean theorem. So I chose to use the Pythagorean theorem on that. So a squared plus b squared is c squared. I just found A. Okay, B was given, and I'm looking for C. So I took 70.7 squared. Got a little bit of a glare going there. Plus 39.2 squared. And then to solve for C, because that's a c squared, I do need to take the square root of that. So I'm going to take the square root, and I get 80.8. All right, cool. Let's do another one then. So the last one I gave you the stuff in kind of word form. This time, oh, you see it's kind of bleeding through a little bit from one below it, or maybe something I wrote on top of it. You can kind of see a C there. That's okay. That's okay. So here's what I've given you. I've given you this angle up here is 60, and I've given you that's 10. So I want you to find the missing angle, that one right there, and these two missing sides. Well, the missing angle, you might could even do that one in your head. Okay? So that missing angle, if I just go ahead and put this in here with everything nice and labeled here, we have, oh, why did I put beta right there instead of B? That should have been alpha right there. I don't know why I put a beta right there, but that should definitely be an alpha. Oh well, it's good for you guys to see mistakes. That way you don't feel bad when you make them too. I know it should be an alpha because it's opposite A. So I don't know what I was smoking, then I put a beta there, but whatever. So we know these two angles add up to be 90 degrees. One of them 60, so the other one's going to be 30. Now I chose to use the sine function of this angle because I knew this opposite was 10. Right? So I had to use some trig function that involved the opposite. I just chose the sine. I could have used tangent as well. Okay? But I chose sine, so I did opposite over hypotenuse. So the sine of 60 degrees is 10 over c. Now this is where it might get a little bit tricky here. Because if I've got sine of 60 degrees is 10 over c. Let me write it like this so it's a little clearer. To solve this, I'm going to multiply both sides by c to clear up that fraction. So I get c times sine 60 degrees equals 10. And then to solve this for c, I'm going to have to divide both sides by sine 60 degrees. Now, you might be looking at this saying, I know what the sine of 60 degrees is because you told me to memorize it, and I did. And I say, good for you. I'm glad you did that. But you don't have to have it memorized at this point. Or sorry, you don't have to replace the memorized version at this point. You can just kind of leave it like that, and then you can just put it in your calculator to get that approximation. This is a little different than the last one we did, where the variable was on the top and you just had a constant on the bottom. You're able to multiply both sides and then be done. But here, because my variable was on the bottom, I multiplied both sides by that variable, and then I had to divide. That's really the same thing as cross multiplying, is really what I did. So if you do it like sine 60 over 1 equals 10 over c, and then you just cross multiply, you get c sine 60 equals 10 times 1. So that's really what just went down. Okay, so grabbing out the calculator, we get 10 divided by the sine of 60 degrees, which is root 3 over 2. We get approximately 11.547. Then we can use the Pythagorean theorem to finish this out. So a squared plus b squared is c squared. B was given to us, and c we just found. So plugging in all these numbers here, and then subtracting 100 from both sides. And then remember, you got to take the square root of this 33.333 business, and you get 5.774. Be really careful when you're doing these. Don't round too much, okay? Don't look at this and round it to be 12. Okay? Take these out to a few decimal places. Otherwise, if you round too soon and then you have to like square things and square root things, you're going to get what's called a compounding rounding error. Okay? And your answer is going to be way off, even though technically everything you did was correct. You just rounded too soon, and then that rounded number that just kind of, it just ended up breaking bad for you. Okay, one more. And that will finish us up for this section. So let's solve for x. You probably want to see the problem. All right, what's better than one triangle? Two triangles. So we want to find this full distance right here. Okay. Now, because this is a right angle, we know that this too is a right angle. So we have two right triangles. All right, cool. So here's what we're going to do. We're going to break these two right triangles up into left and right. And I'm going to solve for the base of this one and then the base of this one and add those two numbers together to get that full distance. So this one on the left here is this. Now you notice I called this x with a little subscript of 1 here. You could have called it anything. Just don't call it x, because x is that full distance. I just called it x sub 1. You could have called it, you know, I don't know if you wanted to call it b, or if you wanted to call it r, q, triangle. I don't care. Whatever you want to call it. I don't need to know everything, okay? I'm not solving this entire triangle. I'm just finding x. I don't have to find all the missing sides and all the missing angles. Okay, that's really important to notice. So I don't have to worry about what is this angle and what is that distance. We don't care. I just need to know what's this base down here. So I've got this opposite, and this is the adjacent, so it makes sense that I'm going to use the tangent. So the tangent of 63 degrees is opposite over adjacent. I multiplied both sides by x sub 1, and then divided both sides by tangent 63. You could have also chosen to use the cotangent if you wanted to. I just don't tend to think of those reciprocal functions. So my first instinct is just to use sine, cosine, or tangent. So we get 82 over tangent 63, which is about 41.781. Now that's my first little segment of x. That's why I called it x sub 1. The right triangle over here on the right also has a height of 82. The base I called x sub 2, and then that angle over here is 39 degrees. Again, all I'm looking for is this base. So again, I'm using the tangent. The tangent's the opposite over the adjacent. So it's 82 over x sub 2. Multiply both sides by that denominator to clear up the fractions. To solve this, I got to divide both sides by tangent 39, and then just use the calculator. X is going to be the sum of x sub 1 plus x sub 2. So I add those two together to get that total distance there of 143.043. Now, this one, how did you know not to solve for everything? How did you know not to find all the missing angles, all the missing sides? Well, it doesn't say solve the triangle. It just says solve for x. The previous ones just said like solve or solve the triangles. So that's the difference in those. All right, so that finishes us up for section 7.2.